C7, reduction formula for sine integrals. Now, this is an integral that we're going to need in our course later. We integrate from 0 to pi over 2 the sine of x to the nth power. Now, we should be careful here with the notation. When you deal with a sine function and you see something like this, or a cosine for that matter, that superscript there is a power. In other words, you're taking sine of x and you're squaring it. So when you have sine with the n there, you're really talking about the sine of x to the nth power. That's what you mean by that. That's notation. So we want to be careful that we understand that. And then you got to be very careful, because here, if the sine has the 2 superscript with the parentheses, that means something different. That's the second derivative of the sine of x. So we're interested in doing this integral, and there's a trick. The trick we're going to do, in going from 0 to pi over 2, we're going to write this, which consists of sine of x with n factors. We're going to write n minus 1 factors, and then sine of x, the other single factor. So when you take the product, you're going to have the sine of x as a factor n times, n minus 1 factors here and 1 factor there. So this is equivalent to what we have. Now, this suggests when we have something that looks here complicated or scary, and something that looks easier, this suggests an integration by parts, where we're going to look at, say, 0 to pi over 2 of a u dv. And an integration by parts, you basically exchange the u and the v. Let's review integration by parts. I like to do it by the product rule. A differential of the 2 variables, a product of 2 variables. You take the differential of the first times the second. I'll put the second there first. And then you take the first times the differential of the second. And you could think of that as the product rule, because if we were doing, say, derivatives like this, that's what we would do. We would take the derivative of the first times the second. I'll put the second first. And then we would have the first times the derivative of the second. So this is the differential form of the product rule. And then what you can do here is we can look at this u dv as equal to d of uv minus v du. And we could put integral signs in front. And this one here, we're hoping by being replaced by this here, that this one would be, we're hoping this one is easy. And this one is trivial, because if you have a differential and you're going to do the integral, this one's going to just wind up to be uv. And here we're going to be going from 0 to pi over 2, so we won't worry about adding the constants, since the constants would subtract out. So let's write this again down here. The integral of u dv equals the integral d uv, the product, and then we're going to have minus v du. Now it's time to identify what we have up here. So we're going to write these down underneath it. U is the sine taken as a factor n minus 1 times, and the dv is sine of x dx. Now I like to have all four components down. We need to get out of this one a du and out of this one a v, because you see in the formula you have a u, you have a du, you have a v, and then you have a dv. So here we only have half of the things. So here we'll do the du first. But let's think of this first by taking a derivative, du dx. That would be d dx of sine. And now I'm going to write the sine of x like this with the n minus 1 on the outside, all right? So here what we would do is we would use the chain rule. We would take here the n minus 1 and bring it down, and then we would have sine of x to the n minus 2, and then we would have to take the derivative of what's inside using the chain rule. So this would be cosine of x. So here, we're kind of reviewing this here, that what's inside of here, if we call that, say, some z, we're using the chain rule that we're taking here the derivative. So this is z to the n minus 1. We're taking that derivative with respect to z first and then doing dz dx. So this is the chain rule. So the derivative of z to the n minus 1 with respect to z is just pull down the n minus 1 you have then. Well, let's just go ahead and do it. This would be n minus 1 times the z to the n minus 2, and then the dz dx is the cosine of x. And then for the z, you just put in what it is. It's the sine of x, and you have it. So this is a little review of the chain rule, which is what we're using here. Okay, so now that we have that, we want to get out of here. We want to get here the v. Well, that's easy because v would be equal to minus the cosine of, when you take the derivative of v with respect to x, dv dx, you get here minus the derivative with respect to x of the cosine, and the derivative of the cosine is minus the sine, so you have minus the sine, and these would cancel, and as they cancel you get the sine of x. So dv dx is the sine of x, so that means dv is the sine of x dx. These are the corresponding forms. So then we have all four things here. We have 1, 2, and then here to find 3, what we're going to do is we're going to write this out. The du is equal to n minus 1 sine of x to the n minus 2 cosine of x dx. And then 4 is minus cosine of x. So these are the four components that we need. Now we're ready to plug in and do it. So this integral here that we're looking for, I sub n, is going to be, well, let's write out all the steps again here. We're going to go from 0 to pi over 2 of duv minus 0 to pi over 2 of the v du. Now this first one basically lists the differential, and you get uv from 0 to pi over 2. And then the second one we'll just write down and deal with it in a second. So here, what is the u? Now we go back up to here, we plug in. This is the sine of x to the n minus 1 power. And the v is negative the cosine of x. So I'll put the minus sign there and have the cosine of x. And we want to go from 0 to pi over 2. At the upper limit, you have pi over 2. The sine of pi over 2 is 1, but the cosine of pi over 2 is 0. And the lower limit, you have 0 for x. Well, the sine of 0 is 0. So in other words, this one's going to be 0. So we're simply left with minus v du from 0 to pi over 2. And now we go find what v is. V is minus the cosine of x. And what is du? Well, we have to go up here and find that. Oh, du looks like a lot of stuff here. So we just have to be patient and put all this down. So this is n minus 1. This is the sine of x to the n minus 2 times the cosine of x. And then there's a dx at the end there. And we're going from 0 to pi over 2. Wow, there's a lot of stuff there. Well, let's first of all notice that the two minus signs will cancel here and give us a plus sign. So then we're going to have, well, also a constant can be pulled out. So let's pull out that n minus 1. Let's get that out. And then we'll have here from 0 to pi over 2, we're going to have cosine of x and cosine of x. So that's cosine squared of x. And then we're going to have here the sine of x to the n minus 2 power. That still looks a little bit tricky to do here. Well, let's replace the cosine squared with 1 minus the sine squared of x. Now we'll have two integrals. So let's be patient and write those out. We'll have n minus 1 out in front. And the first integral from 0 to pi over 2 will be 1 times the sine of x to the n minus 2 power. So that's the first one. Then the second one here will be n minus 1 with the minus sign here. So that's minus n minus 1. And then this has to hit that other sign. So if we do that, this is interesting because we have a square here, sine of x squared. And here is sine of x to the n minus 2 power. So when you add the exponents, you just get the n. So this is going to be sine of x to the nth power dx. And now we see that this is the integral that we started with. This is in. That's the integral we started with. So let's continue simplifying. Let's also note, though, that this is this integral where the n is n minus 2. So this is the idea of a reduction formula. Some kind of a recursive thing is going on here. So we have the integral in is equal to n minus 1. That's this part we're bringing down. And that's going to be multiplying I dn minus 2. Then we're going to have a minus sign. Then we're going to have n minus 1. That's this one. And then we're going to have I sub n. That's this one. Now what I would like to do here is work out on the right-hand side by, well, actually I'm going to leave this one alone, n minus 1, I, n minus 2. But I want to work out the second one because this is minus n in, but then minus minus is going to be a plus 1 in. And I see that this will cancel. So by canceling that, I'll have 0 equals n minus 1 I subscript minus n in. Let's go ahead and separate that out like that. And then this here, we can bring this on the other side of the equation and have n in is equal to n minus 1 n minus 2, like that. And then what we can do is we can write in is n minus 1 over n minus 2. So this one has less of a power. And you can imagine writing this one again, where you have an n minus 2 here, n minus 4, and keep going down till you get to something real simple, and then build up. So here, if we go back and put in what these are, the I integral with the n is 0 to pi over 2, and that's going to be the sine, and I'll go ahead and use the notation we had earlier. This is sine of x to the nth power. All right, just remember this is the same as sine of x to the nth power. And that's going to equal n minus 1 over n. And we're going to have the integral from 0 pi over 2. So this is our formula, the reduction formula for sine integrals that go from 0 to pi over 2. And we will use this later in our course. Now, normally when we get to that point of our course and we get an integral like this we need, we would look it up. But in this course, we derive everything, we show everything. So we derive this, think of this as deriving something for our integral table, which we'll come back and refer to later when we need it. See you next class.